Yeah, because I'm not getting anything from her.
I was worried because I couldn't put my phone in. Did we schedule it again?
No, we didn't. I sent a message saying I was going to be a few minutes late.
Oh.
And then I said, okay, are we having our meeting? Because no one had started.
Hey. Okay. So since we have assumed the population standard deviation was known,
let's get this money back where you belong. With Jake.
I put C, we assume it's unknown.
Look, there's Jake. He's heading to the school bus. We have to get money back to him now. I'll make a little bunny-sized parachute.
I don't even remember reading about that.
That's why we do the T-score instead of the Z-score. Because we don't know the standard deviation.
Oh, right. And then with the other one, it was we don't know the mean, right? The confidence interval? The population mean.
I don't know, but that's not asked here, so we're good.
Okay.
Because I don't know.
Sounds good. Okay, the null hypothesis is equal to 8, and the alternative is greater than 8. And the population standard deviation is not known. Becca collects the sample of 9.
No problem, Jake. We're
Thanks.
so glad we could get you and your buddy back together again. Bye.
Clearly that speaking is really setting in now. So we need to do the T
Nothing like get money back to
equals
Jake.
bar.
We made him so happy.
Yeah, so T is, the formula is T equals X bar minus the mu.
Over sigma divided by the square root of the number, right?
Not sigma, because we don't know sigma.
Oh,
It's the standard deviation. It's the population standard the sample standard deviation, not the population standard deviation.
I have S, right?
Yeah, but sigma is
That's
the
what I.
O with the tail.
Yeah. I just my brain. Okay. It's Friday. Okay. So X is what then?
What are you saying?
Oh, okay. Never mind. It's right there. My brain is struggling today. Okay.
So for 4, it's no, because we don't know it. And then you're working on 5.
Okay. That's what I thought. Just checking. 5t equals 11 minus
8,
8. Okay.
because that's the null hypothesis. So that's the mean.
Is it always that way?
Yeah. The null hypothesis is always equal to the
Yeah.
population mean. Yeah, the mu.
Okay. And then
Aurora Joy put mommy's TV back.
square root 9.
Do not push on it like that.
Did you get
Stop.
1.5?
1.5.
Okay.
Yeah, 1.5. I'm sorry.
You're fine. Using the following values, which will I have to pull it.
It just wants you to take these numbers and copy it in. You don't have to pull up the data file. So you can literally just copy it and then paste it into the SPSS.
We are a tiny team. We go behind the scenes. There's nothing we can't do. It's me.
Using the no pocket cake.
You want something? Big for that? Oh, good.
Are you getting it?
So when we do X, are we doing the explore? Analyze, explore.
You can do either for X bar, but you have to do the compare means to get the t-score and the p-value.
So you go in and press statistics descriptives, right?
Here, let me share my screen because I got it up.
But
Can I share my screen? How do I share that? I always forget.
it's over in the top corner.
Okay, do you see it?
Yeah.
Okay, so analyze, compare means,
Ah, okay.
and then one sample t-test, and that's what I have pulled up here, is this.
Okay, that's where I get confused. I'm like, which one are we supposed to do? Okay.
And when you do that, you have to put in the mean. This isn't the right data set because this is a different data set.
So one sample t-test, and then you go and you add that in. And you just press OK. Oh, well, you have to add the p-value. Which was 40. That's
Are we on? Which question are we on?
5.
Okay.
I put 40 in the test value spot.
No, it's 8.
Oh, I'm sorry. I looked at 5.
That sound?
Or 10, sorry. Yeah.
Yeah, if we're still on question 5, then the test value should be 8.
I thought 40 seemed off, but I was like, okay. Okay, so let me hurry and fix this. Hayden, get out! Hayden, get out. Get out. Sorry. Crazy 5-year-old. Oh my god. I have to stay off right now. Go tell Daddy! One's chasing our cat, the other one's saying there's no toilet paper. Okay. Okay. Get this in here. And then it's 8.
Wait a minute. Wait a minute. We're not on question
What?
5.
Oh, 6. Sorry.
I was like,
So
what?
it's not. Should we put 98.6 then?
Yeah, I'm sorry.
No,
Yeah.
it's not your fault. Okay.
98.6.
It made sense because we just dealt with it. Anyway. 98.6. Okay. And we're trying to find T, right? And it 433.604.
If we're on 6, we're looking for X bar. Which is it'll just say mean.
98.2.
I got 98.22.
Oh, well, yeah, that's what I got. Okay.
Yeah.
98.220.
Yeah. For the standard deviation, I got 0.922. Hey, Leah's here.
She is?
Yeah, she just joined.
Oh, look at that. Okay. Centimeter S. .922, you said, right?
Yeah, that's what I got.
And that's S?
Yeah.
T is negative 1.843.
That's what I got.
Hello, guys.
Hi.
Sorry, I was eating dinner and I forgot.
I've done that before.
But I have all the homework done, so
So everybody did it but me.
Did you do the group quiz?
I'm sorry?
Did you do the group quiz already?
No, but I did the homework.
Oh,
Okay.
we're working on the quiz now.
Okay.
We're on question 9. Get out of my room!
My daughter's laughing at you.
My heavens. They're like little psychopaths. My friend told me the best mother.
They are yours.
I know. My friend told me the best quote about motherhood. She's like, being a mother is like being pecked to death. Oh my gosh. Yes.
Okay.
Okay, so we're on 9.
Do you want to work through the problems, or do you want us to just give you the answers?
Or the answers that we came up with.
Yeah.
I'm cool with the answers.
Okay.
Okay.
1 is true.
I got that. I got 1 and 2 is true. Let's see.
So 3 is C.
Right? And then
4 is no.
10,
5, 1.5.
and 9, and 10.
you say 1.5?
Yes.
10.
6 is 98.22. 7 is 0.922.
Okay.
And then 8 is negative 1.843. I think that's where we've stopped.
Okay, and we're on p-value.
Yep.
I found this really cool thing. It's kind of like the probability applet, but not. Let's see. Let me see if I can find it again.
So the p-value, don't you put it in the applet?
No,
Yeah,
you
but-
can't.
You can't put it in the applet because it's not right. However, you can find a t-distribution applet.
What? That's cool.
Yeah, but
Is it actually called applet?
That is how I search it, yes. It's not through BYU, though. It's through the University of Iowa.
huh.
Okay, so
Well, if you have the SPSS one sample test up, it's the SIG two-tailed.
Oh.
As long as the probability is two-tailed, it's SIG two-tailed. If it's one-tailed, you have to divide it by 2.
So it's
right, but it's not
0.81.
because
What'd you
the
say?
mean is less than. What's the degree of freedom?
For what test?
Gibberish to me.
For like, what's the sample
Yeah.
size?
Is that DF?
Yeah, DF. What's the degree of freedom?
19.
So there's 20
Yeah.
things. Okay, so 19, and it's this one. So 0.95951. I think that's right.
The p-value?
Yeah, because
1.
it's looking for greater, right?
0.081. Is that what you got?
No, I got 0.41 or 0.041.
What? We
Yeah,
all
but
got
you're looking for the p-value. It's trying to see what the alternative hypothesis is talking about if it's less than. No, you're right. You're right. I did that wrong. Let's try this again.
Well, hold on, because I don't have the SPSS data set up. So let me just do that.
.040.
Okay. Where's mine? Why did mine set up wrong?
Okay, we're still doing it for the temperatures, right?
Yes?
Yes.
So it's supposed to be one-tailed.
Right.
Oh, mine came up two-tailed.
Well, in SPSS, it'll always come up two-tailed. But you have, if it's
Divide it?
one-tailed, you have to divide it.
By 2, right? By
Yeah, I
2?
just put it into this applet that I found.
Here,
So 0.041. Okay, I got it.
yeah.
And how did you know it was one-tailed?
Because the alternative is.
Okay, guys, look at my screen.
Hold
So
on, I
this
gotta
is
pull up my
the-
camera again.
This is the thing that I found. So the X is going to be your your test statistic, and you put it in there, and whatever it is. So the degrees of freedom, and then whatever you're looking for. So clearly this one right here is two-tailed, and then whether it's left-tailed or right-tailed, and then you just hit enter, and it tells you what the probability is of it.
Well, that's cool.
Yeah, and I used it for my homework last night to figure out, because clearly the normal probability applet didn't work, and it helped me a lot.
That's good to know.
Yes.
How did you find that?
I Googled.
What did you Google?
Yes. So I just Googled T-distribution applet, and it's from the University of Iowa. And it comes up just to that page. You don't have to search for it or anything.
Okay. Perfect. Okay.
Well, I didn't round properly. But I guess it's close enough. But the answer is .041.
Okay.
So for 10, we reject the null. That's what I got. Aurora, stop touching. Stop.
Hey.
Are we all good on 10?
Right. Now we're on 11.
Okay.
I am inputting the information now into SPSS. Okay, so we got count. Maybe 40 minutes in plans for yourself based on. For 11, go into the p-value application.
Seriously?
Oh, I found the split. So
You want to study?
we
You don't want to study?
to find the information to find the p-value, right?
Remember I explained it on the study?
Are you using the applet?
Yeah.
Okay. Well, I got.
And the test value is 40, right?
You don't want to do it.
So T 20 X bar. Leanne, how do you know which one you're supposed to put in on the applet? I'll show you.
It depends on what your alternative hypothesis is. So this is saying for 11 that the first alternative hypothesis is
Different.
so it's going to be the one that says 2p, the two-tailed one.
Oh, this one. Okay.
Sorry guys, I'm trying to pull up my SPSS.
No, I'm fine. Do we have to enter something in? Oh, no. Dang it. 40.04. Will you just press enter? What am I supposed to put in the red spot?
Nothing. The answer is where the red spot, like the red spot is the answer after you type in the information. You just hit enter.
Keeps coming up as 0.
So if you put the degrees of freedom in and the test score.
Yeah, here, I'll show you. This is what I did. Here. Yeah.
That's a really high test score.
So, did I do it wrong?
I don't know if you've. I think it's right based on what you've put in, but I don't think that's the right answer, if that makes sense.
Yeah.
Okay, so for 11, I got 0.368.
Why?
Just so you guys have a comparison number.
I don't think it's giving me the number. So, it's two-tailed, right?
Yes, because
Yes.
it's not equal to.
So it's 0.995?
Well, not.
Or sorry, the one sample test. I have two different answers. 0.081?
So I don't use the you guys' applet. In SPSS, it's the SIG two-tailed answer, and it says 0.368.
Mine says 0.081 in SPSS.
Is that the right data set?
I thought.
Okay, hold on. Let me just read it. No, don't say
Try
that.
again.
Okay, so we're still on 1.
I brought a surprise snack for me. What do you see?
Yeah, mine says 0.368. You're on the other data set.
So I put the data set in. Compare means. One sample test. That
Don't go to bed yet.
test value I put 98.6, right?
No, we're on question 11, so it's 40. You're on, yeah.
What's wrong with my brain today? Oh. Okay.
So you need to make sure your data set starts with 59 and ends with 61.
data different. It still comes up 0.95.
I mean, that's the probability for the data set for the temperatures. Maybe, I think. But we're doing the baby boom data.
That's the data I put down. Weird. Why? Hi, Rosie. How you doing? Hey. Okay. Can you help me? Be a good luck charm. Okay. That's a 40. Yeah, mine's not changing.
Okay.
What did you get, Leanne?
Hold on, I'm trying to work it out.
And I'm Chill. And I'm Millie. We're so glad you're here. Really, butterfly. Like butterfly? We can do. Look at that. We see a butterfly. Yell, firefly.
I've done it like 6 times and I get the same answer.
Right? Weird.
Like, do you want me to screen share with you and show you exactly what I'm doing?
Sure.
Okay. As soon as you can see.
Hey, look. The little butterfly found a friend. Now how many butterflies are there?
Okay, can you guys see it?
3.
Yeah.
Okay, so I'll just completely close out of this. Start all over. Okay, so this is the data set 59, 14,
So did you
37.
type everything in there by yourself?
No, I just copied it and pasted it. So that's why this is all gray, because I just selected it and then copied and pasted it here.
That's what I did.
Yeah, I actually downloaded the file.
Okay. And then I select Analyze, Compare Means, oops, one sample test, variable 1, and the mean is 40, test value is 40. So hit OK, and this,
That's
oh, shit.
0.95.
I've done it like 7 times. Why is it different now? Okay, hold on, guys.
Yeah.
Don't worry,
49, 40, 37, 66, 68, 17, 15, 9, 56. 52, 55, 14, 4, 47, 61.
We'll call you Cookie Club. Hello. Welcome to the team. Let's get our mighty powers ready.
You gotta be kidding me. This is ridiculous.
You getting 995?
I did it like 7 times, and now it's coming out different.
What'd you get, Leanne?
Nothing yet. I'm gonna copy and paste because there's more information inside this other thing.
Oh, gotcha. Say hi. Say hi. Say hi. Say hi. Yep. Okay.
Okay, we're almost done with this shit. Am I still sharing my screen?
Yeah.
Ugh, okay.
Wait, not anymore. No.
Okay. So now I'm
Okay.
getting 0.995.
I think it's 0.995.
Okay, I figured out what you were doing wrong in the test statistic. You were putting the mean in there.
Are you talking about the applet?
Yeah, the applet.
Okay.
Oh. Am I supposed to put the X bar?
No, you're putting the T score thing the test statistic.
Oh. Okay.
Here we are at the supermarket.
0.006.
The door is closed. How do we get in?
Ah.
It's automatic.
0.995.
Oh, supermarket doors are awesome.
Okay. It's 0.995. Okay.
Oh, look at this.
Remind me how we decide if we reject the null or not.
If P is less than alpha, reject the, okay, P-value less than alpha, reject the null.
Okay. So we don't on 12 we fail to reject, right?
Yes.
Okay, so 11 is 0.995. Is that what we decided?
That's what we're going with.
Okay, because that's what I got. Okay, just making sure.
Okay, so I don't know how I was messing it up the first 8 times, but I
No,
guess
it
I was
happens.
doing something wrong.
Sorry, I just had to have all the information in front of me so I could work it out and then put it in.
Yeah,
Okay.
no, that's understandable.
Let's see. This time, less than 40, and you keep the same level of significance.
Put the raisins back. So I put it would decrease because you're only doing half of it anyways.
It would, because everything stays the same, right? Except for the fact that it's one-tailed instead of two-tailed, so it would be 0.502.
How can you tell if it's one-tailed or two-tailed?
So if it's not, so if the alternative hypothesis is not equal to, it's two-tailed. If it's greater than or less than, it's one-tailed.
Oh. Oh, okay. Gotcha. So then you just divide it by 2 and then it. Okay. I got it.
So if we had done it, it would be 0.498, right?
Well, I got 0.502, but yeah, it's close enough.
Wait. The p-value divided by 2.
See, I didn't do the p-value. I just typed in, like, I just changed it to 1. I took
One tail.
0.006, changed it to 1 tail, and I got 0.502. But either way, it's still in the same ballpark, and you're still failing to reject it because it's not less than,
Yeah,
right?
right. So 15, compare the width of the confidence interval for question 11 to confidence interval for question 13. Which one is wider? So I put they're the same because all you're changing is the probability, not changing any of the numbers.
You decided on B? No, A, sorry.
For 15?
14.
Oh, 14 we fail to reject the null.
15 compare the width. I don't know 15.
15 I put C. I'm just waiting for a consensus. What do you guys think about 15?
I will.
As technically we're not changing the confidence interval.
No, I think all we're changing is the probability. So all the other numbers should be the same.
Okay, C sounds good.
B sounds good.
Okay, well we got 100.
Oh, good.
So I'm glad y'all fixed me on that one question. I don't know what I was doing.
It happens.
Okay.
Okay. Should be interesting to do the
To what?
presenting, so I'm sure that's gonna be a struggle for me. Oh well. Sounds good. We're done.
Yep.
Okay then. Are we good to go then?
Yep, I think we're good to go.
Yep.
And
Sorry I was late, guys.
no biggie. No biggie.
I didn't have my phone on me to remind me. So then it was like, oh, it's 7:30.
Whoops. No big deal. Okay. Well, we'll see you
Cool.
next week then.
Yep, sounds good.
Okay, bye.